Hey guys, the last time on 8.4 we talking about how to establish identities, and I give you guys some tips with like the 5 algebra skills, and also a list of the identities like that we learned from chapter 7. So make sure you have them out in front of you in case like homework and assessment. Okay, so for 8.5 today we're gonna learn more identities, and we're gonna also use them to establish new identities. Okay, so before we get started, let me tell you guys a common difference. I mean, a common mistake that a lot of people like making in this class. Okay, so say what if like for some like nice day I want to know what the value of cosine of 60 plus 45 degree is, right? Like we all know that first of all we're gonna use PEMDAS or whatever like inside of parentheses. We're gonna do it first. 60 plus 45 we're gonna get cosine of like 105, right, degrees. And after that, if you put it into like a nice calculator or like a fancy one, a Casio one, I guess, it's gonna give you like the exact value. By the way, like if you see the word exact value in the test and like quizzes, you know that it has to be like like it's exact value. It cannot be in decimal. Okay, like this is not exact value. Okay, this is, but like decimals are not exact values. Okay. So anyways, like if you have like a nice calculator, it's gonna give you the exact value, and then you can approximate it by putting it back to decimal. If you compare this in here with like the split of them, like the addition, but of each angle inside a function, you will see that they're not equal to each other, right? Like cosine function is not distributive in the sense that you cannot do like, oh, I'm gonna get like cosine of 60 plus cosine of 45. They are not equal to each other at all. Okay, so let me get rid of all of this and let me just like mark them out for you. As you can see, a big like discovery that we have in here is that cosine is not distributive at all. Okay, so make sure you don't do it like ever in the future. Okay, because this number that we have in here is different from that number. Okay, so what happened if we want to find a sum, right? Like how can we get to this value if we don't know how to find it, right? Like say if you have like a TI, how can we get the exact value? Well, a lot of mathematicians have like work onto that and then figure out like new formulas, right? And then I'm gonna show you guys all the formulas in the next second, and I'm not expecting you guys to remember all the new formulas that we learned with it today. Just a heads up, we're gonna have like 6 or even more than that. But make sure you print them out like in front and have it in front of you, okay? So now talk about the reason why like cosine or any trig function is not distributive in here. Is that just imagine like if you start with this picture in here, we all know that cosine is the x-axis and psi is the y-axis by now. So then in this picture I'm gonna talk about like the cosine of a sum of the angle, which is cosine of like 105 degrees. Okay, so what do we have in here? We have like in here we have like 60 degrees, right? And then on top of the 60 we adding 45 degrees. Okay, so together this angle from here to here, it is 105 degrees. Okay, and then 105 degrees is going to end up having like this point here on the second quadrant, and then obviously everything on the second quadrant is x-axis. This x value has to be negative, right? Because on the left hand side of the x-axis, and that's why we have like a negative like value for it. But if you consider like each like the cosine functions in here, first case, let's talk about cosine of 60 first. So we know that 60 is like right there, right? Like like closer to 90 compared to 0, and it's on the first quadrant in here, right? And we know that the cosine value of it has to be like toward the x-axis, which is like 1/2, right, or like 0.5. Okay, and let's talk about the cosine value of 45 degrees from 7.3, if I'm not wrong. We learned about all the special triangles, and from there we learned that cosine of 45 degrees it equals to square root of 2 divided by 2. And again, 45 degrees is this one is like halfway between 90 and 0, while 60 is like like 2/3 of the way between 0 and 90. Okay, and again the 45 degrees is also in question 1, right? Nothing special about it. But then like obviously if you add something like this, like 1/2 to square root of 2 over 2, you obviously cannot get a negative number, right? Like you cannot get this number as equals to negative 0.26, right? Because like a positive number plus another positive number, It just simply cannot make a negative number, okay? That's why in here we have this discovery, well, that says that a cosine function or any trig function cannot be distributed to anything, okay? So, question, how can we compute trig values of a sum or even a difference of two angles in general? Well, here, let me tell you guys the formula to get to that, okay? So just imagine that this formula in here is given to you guys. Like, I'm not going to ask you guys to, like, derive it because, you know, it's hard and complicated. And honestly, I don't even want to do it myself. So, again, you don't have to memorize it, but make sure you print this page out and have it in front of you, okay? Or actually, I do have a summary for this page. So, even if you don't want to derive or, like, come up with how these formulas are, like, that way, you don't have to print out this page, okay? Like, you're, later on, I'm going to give you, like, a box of, like, formulas for this, okay? So this one is given right here, right? We just have like believe that is true without proof, okay? Actually, if you want the proof, you can read it in the textbook. It's complicated, to be honest, and it's also online. A lot of like proofs can be given for this like green highlight in here. And if you want, I can explain it to you if you like schedule a Zoom meeting with me, or if you like ask me how to derive it, okay? So now, because we have like the addition already, right? We have like the sum of the angle already, right? So what will happen if we have like a difference of the angle? Well, notice that a minus b is the same thing as a plus negative b, right? Like they're the same thing. Plus times minus is a minus anyways, right? Like we know that. So now, because we have this formula right here, so our b in this case would be our negative b, right? So b is negative b is negative b, and a is just a, right? Minus is minus, okay? And we know that cosine is even function and sine is an odd function. That's why for cosine, like we're gonna cancel this negative and it just be like positive b in there. And then for sine here, we're gonna bring out the negative in front, and that becomes a positive, right? And then for like the inside of the second term, we're gonna have side b, okay? And this one is like the second formula to get like the, what is it, the difference angle of cosine, okay? So now let's talk about psi functions, because we finished like the sum and the difference of cosine already. So by the cat or by the complementary angle theorem, we know that psi of theta equals to cosine of 90 minus like theta, right? So imagine if you're gonna have like theta equals to 60 in here, psi of 60, of course it equals to cosine of 30, right? Why is that so? Because cosine and psi, first of all, they are cofunctions, right? And if you don't know what cofunctions are, make sure you look back in chapter 7. I'm not sure what section it is, but make sure you look back in there to figure out what cofunctions are, because chances are you're going to see them in the test and like in the final, okay? And then the reason, the second reason why this identity is true is because 90 plus 30 is 60 plus 30 is 90. There we go. So the sum of the two angles in here, they have to add up to 90, right? So if you add up these two angles in here, obviously the theta will cancel each other out, and you end up having pi over 2 or 90 in here, okay? And similarly, if you like swap the role of like sine cosine, because psi is a cofunction of cosine, and then cosine is also a cofunction of psi, right? So then you're gonna have the like the thing in the rest circle in here, okay? So we're gonna use that compare and also like the formula from before, and then let's talk about psi of a plus b, right? So psi of something, treat this one like something in there. It equals to cosine of pi over 2 minus that something. So this one just copy and paste in there, okay? And again, we're using like this formula from here, okay? And because we do have the formula for cosine of something minus something from before, here, let me make a better arrow. It's actually from here. Cosine of something minus something, okay? So in this case, a would be pi over 2, and b in here would be a plus b, okay? So again, this is, you know, like a, and this is a plus b. Oh, actually, no, my bad. Here, let me backtrack a little bit. Too fast. All right, so what do we do when we have parentheses, right? We're gonna distribute a negative into a and b in there, and then we're gonna get like a negative a and negative b right there. And now I want to like group these two together, right? So I have that as a group, and this one in here, let me circle it in pink, I guess. This in here would be in roll up A, and the B in here would take the roll up, you know, just B, right? So wherever we have A on the cosine formula in here, that would be replaced by pi over 2 minus A on the cosine, like up in here. Okay? Okay, it's pink. So here, let me put it in pink. Okay, so then similarly, we're gonna have this formula in here. So instead of A, I'm having pi over 2 minus A, and in here again, instead of having A, I'm having pi over 2 minus A. And then cosine B and sine B is just the same thing, right? So now we know that cosine pi over 2 minus A is the same thing as sine of B, right? By the cat again. And then same thing goes with this one. We know that sine of pi over 2 minus A is the same thing as cosine of A. Okay, so this one is like sine of A. Okay, so putting them together, we're gonna have this formula right here. And this is to find the sum of sine. Okay, and similarly with like the same logic as before, because A minus B can be written as A plus negative B, right? So then we repeat the whole thing that we did for cosine of A minus B before, but this time we're going to use sine of A plus B, okay? And then we end up having this formula right here for the difference of sine, okay? Tangent is going to be harder a little bit in terms of, you know, like tangent is sine divided by cosine, right? So we have to do a lot more, but that's okay. Okay, so let's see, what do we have in here? I'm thinking I didn't finish this one, but here. First of all, by quotient identity, we know the tangent equals to sine divided by cosine, and this one is just the angle, right? So we copy and paste them down here, okay? So sine of A plus B is this formula right here, and cosine of A plus B is this formula right here, right? So we're gonna put them together, and here I didn't put like the cosine of A plus B here, so let me put it down here really quick. I'm gonna get cos A, cos B, minus sine A, sine B on the bottom. And if you notice, I don't put parentheses over A and B anymore because, I don't know, like I'm lazy, but if you want, you can put it there. Like it doesn't matter. It doesn't matter with or without a negative, okay? But if you have like more than one thing inside a trig function, say if I have something like cosine of A plus B, you have to put parentheses over them, okay? Because it's not like a single thing anymore. It's like two things in there. There's like a group in there, okay? So let me take that out. And now let's talk about the next step in here. So what do we do? Well, we're gonna try to get them divided by cosine of A times cosine of B. Why is that so? It's gonna give us something like nicer. That's why we have to do it, because this formula right here, like this formula in here, looks like long and ugly, at least to me. And the idea in here is that we need to get tangent, right? And then tangent is sine divided by cosine. That's why we have like two angles. That's why we have to divide all of them by cosine of A and cosine of B, okay? And then if you take this group in here divided by cosine of A and cosine of B will be canceled, and then you're gonna get like sine divided by cosine, which is tangent of A, okay? You do the same thing if you take this group in here divided by this group in here, cosine of A will be canceled, and you're gonna get sine of B divided by cosine of B, which is tangent of B. Okay, same logic. You do it like each of the time in here. The first time you get a 1, and the second time you get a minus. Tangent A, tangent B. Okay, so this is like the third formula. I mean, the next formula that I want to introduce you guys. This is the sum of tangent. And it's very powerful, okay? And then just like before, we're gonna apply the same idea of doing, you know, like the difference by using the idea of A minus B is the same thing as A plus negative B, okay? And from there, we're gonna get a new formula, which is this. Okay, and just a reminder, tangent is odd. That's why whenever you have like, you know, a negative B in there, the negative will be put out in front, and then the angle would become positive, okay? So again, you don't have to learn how to derive them. You don't have to like, you know how to derive them. You only need to use the formula, okay? Like as long as you know how to apply the formulas, I'm good already. I'm cool with it. I'm happy with it already, okay? So now let's talk about the first objective of the day, like finally, right? Okay, so as I promised you guys before, from the last page, we derived a lot of formulas, but technically, there's a summary for them, right? Like, as long as you remember these 6 formulas in here, you're cool, you're safe, okay? And before we jump into the next example, here are some of my like, personal tips again. So always try to find all 4 values: side A, side B, cosine A, cosine B. Okay, like always go with sine and cosine of the 2 angles that you have in there. Okay, you will see why in a second, and it will make sense when it comes to your practice. Okay, and then also recall the 3 Pythagorean identities, because as you see from the last time from 8.4, they are really useful, right? They help us a lot. And then whenever you try to rational, by the way, if you have like a square root on the bottom, try to rationalize it. And how can we rationalize it? Well, we're gonna think of conjugates. Okay, again, I'm not gonna throw something like hard like this at you guys, but I don't know, like things might happen, right? So just like be cautious that is something you might see in the test. Okay, so finger crossed, keep practice. Okay, and last tip in there, watch out for the plus and minus side of the trig value. So this one I told you before, like just because we learned about like positive trig values, it doesn't mean that trig values cannot be negative, right? Like we have reference angle, we know that a trig value, it could be positive, it could be negative depending on where your angle is at, right? Like it depends on like the quadrant where your angle lies on. Okay, so just keep that in mind. Okay, so now let's talk about my example. Okay, so originally this is not there, but like I put it there just to guide you guys. So I'm not familiar with like radians, so like to my personal advice, I'm gonna convert this one to 2 degrees first, and let me do it really quick. If I convert it 2 degrees, I'm gonna get this one as 285, right? So there's a lot of ways to do this because it ends with a 5 in here, so I know that I can make a sum of like 45 and something, right? So I'm gonna do in my calculator 285 minus 45, and that gives me 240, right? So my job right now is to convert them back to radians, because I was given like a radian angle, right? So 45 degrees is actually pi over 4, right? And 224 is actually 4 pi over 3, if you like convert them, okay? So that means that 19 pi over 12 equals to pi over 4 plus 4 pi over 3, okay? So now keep that in mind, right? Like whenever we have the 19 pi over 12, we're going to replace it by 4 pi over 3 plus pi over 4, right? So that's the next step. So right now it has nothing to do with trig functions, right? It's just like conversion between degrees and radians, and we're trying to find like a sum or a difference in here. In fact, you can actually like use an idea with like something minus something in here, but I'm lazy because the 45 is just like right there. That's why I'm gonna use the sum in there, okay? But if you want, you can do something like, I don't know, like 360 minus something, and it like this angle end up to be like a nice number. Like if it were to be a member of the 30 family or of the 45 family, that's great. If not, don't do that, okay? As you can see, the 45 in here is a part of the 45 family, right? And then the 224 in here is a part of the 30 family. That's why I purposely go for these numbers, okay? So yeah, there's a lot of like things that can be done to get the sum or the difference in here, but you have to be smart with this one. You want to have everything in terms of like 30 and 45, okay? Like that will be easier for us to find exact value, because the problem is specifically asking us for the exact value, okay? And we only know things about like the 30, 45, and 60 family, okay? So let me take these out, and then let me get more work in here. All right, so what do we do next? Well, from earlier we have like the sum of tangent formula, right? So I'm gonna go ahead and apply that formula in here. So my a in here would be 4 pi over 3, and my b in here would be pi over 4, right? So I'm having tangent of a, which is 4 pi over 3, plus tangent of b, which is pi over 4, and then divided by 1 minus tangent of 4 pi over 3 times tangent of pi over 4. Okay, if you put everything into the calculator, tension of pi over 3, 4 pi over 3, it's actually square root of 3 over 3, right? And then tension of pi over 4, if you remember from the chart of, you know, like 30, 45, and 60, sine, cosine, tension, you guys can like get this value right here as 1, right? And again, like if it were to be in a person class, I'm not going to allow calculators for this one because I purposely want you guys to know how to find the exact value of tension of 4 pi over 3, right? We can do that by first draw the angle of 4 pi over 3 out. Surely we know that 4 pi over 3 is like 240, right? So 240 is like right here-ish. Okay, so here, let me draw it out. This one in here. So first of all, we're gonna find the reference angle of it, and the reference angle in here is of course this one, that little piece, right? And it's like 30 in here, right? And we know tension of 30 is like right here, right? It is square root of 3 over 3. And because we're talking about the third quadrant, right? That's why tension in here has to be positive, and that's why we have like positive square root of 3 over 3 in here. Okay, but lucky for you guys because this is an online course, so you guys can use your calculator. But if you don't have like a good calculator, some calculator will give you a decimal, which is bad because I'm asking for exact value. So you have to know how to like retract information from this technique of using the reference angle. Okay. Anyhow, get back to the problem. We have that's for the top, and then for the bottom we have a 1 in here. Tension of 4 pi over 3. We're gonna get square root of 3 over 3. And then times 1 for tension of pi over 4, okay? For the top part, I'm gonna like get a common denominator. So the 1 in here will be 3 over 3, and I'm gonna get square root of 3 plus 3 over 3, okay? For the bottom in here, square root of 3 over 3 times 1 in itself, and then again, I'm gonna get the common denominator. So it's gonna look like this, okay? And because we have like 2 3's in here, we're gonna go ahead and cancel them. So the final answer, it could look like square root of 3 plus 3 divided by 3 minus square root of 3. Okay, so this could have been your final answer, okay? Like, if you stopping there, I'm cool, but then just because I told you guys ahead of time already, if you have like a square in the bottom, that's like, you know, like a bummer to me. Like, honestly, it's ugly. I don't want to see any like square on the bottom, so to me, that's not like a proper answer. But like if you can get down that far, like I'm happy with it already, okay? But like honestly, you can do a little bit more, like what I'm about to do right here by rationalize it, by multiply it by the conjugate. So let me rewrite the problem right here. Okay, and the conjugate for the bottom, it is 3 plus square root of 3. And it's duplicated for both top and bottom of like the new fractions in there, and I'm gonna go ahead and, you know, like FOIL them. So I'm gonna get 3 square root of 3 plus 9, and then 3, and then 3 square root of 3 on the top part. For the bottom part, I'm gonna get a 9 minus 3 square root of 3 plus 3 square root of 3 and a 3. Okay, and again, like what I just did in here is just FOIL, right? Like first, inner, out, no, first, inner, outer, and last, or like, you know, first, inside, outside, last. Okay, like either way. Anyhow, let's combine them, right? So this can combine with this. So we have like 3 square root of 3's in here and another 3 square root of 3's. So together they are 6 square root of 3's. Okay, and then 9 plus 3, we have a 12 in here. On the bottom, these two things cancel and we have a 12 in here, right? So then what do we do now? Well, we can cancel each of these by a 6, right? So this would be 1, this would be 2, and this would be 2. So the final answer that I really like sincerely hoping you guys to get in here is square root of 3 plus 2 divided by 2. This is like the, like, I don't know, like a nice answer because there's no square on the bottom and it looks like so beautiful, at least to me, again. I feel like I make a mistake. Actually, I do. Here. This one is not a plus. It should be a minus. And because that is a minus, this cannot be a 12. Yeah, this is what happened when you record things and then try to do math at the same time. So you're gonna have a 6 in the bottom, right? And then with the similar like logic, we cancel everything by 6. So there's a 1 in here, there's a 1 in here, and there's a 2 in here, right? So the final answer will look like different. It is square root of 3, not 1, square root of 3 plus 2. This is it. This is like the like angelic like answer that I want to see. Okay, but of course if you stop in here, I'm gonna give you the full credit for it because you know like it's hard already. Okay, but from my experience from the past, a lot of people tend to do something like this. Here, let me give you let me put it in green. Okay, a lot of people, they tend to do, they apply the formula, like they know which formula to apply, but sadly they would ignore the function. Okay, like they will not even like care at all for like tangent. Okay, they would just use the 2 angle in here. They would just do 4 pi over 3 and then plus pi over 4 and then divided by 1 minus 4 pi over 3 times pi over 4. And this is wrong, okay guys, like don't do this, okay? If I were to have this one, then the formula would look like a plus b and then 1 minus ab, right? This is not the formula though, like, right? Like the formula in here, it has tangents, right? So make sure you attach tangent in front of the angles, okay? Like don't just rewrite the angles by itself like that, it's weird, okay? So now let me put a green star in here for your part, and let's move on to number 2. Okay, use sum and difference formulas to establish your identities, okay? So I give you guys like the 5 tips that we see on 8.4. So these are like all the good tips in there, so make sure you have them in mind. For my example, again, you see the word establish identities, so make sure you guys remember how to do it. We go from the complicated side and we end up with, you know, like something easier, something similar to the other side of the problem, right? So for my part, I'm gonna go for the right hand side because it looks like something I don't know how to do. So right hand side in here, I'm gonna copy it down, and it looks like secant of A, secant of B, divided by 1 plus tangent of A, tangent of B. Okay, so my very first like instinct in here is that I'm gonna put everything back in terms of sine and cosine. Secant in here is to flip up cosine, right? So right on the back, I'm gonna get 1 over cosine and then times 1 over cosine, but then the angle will be like different, okay? All over 1, and then tangent is sine divided by cos, and then wait, this is A. We also have sine divided by cos for angle B in here for tangent of B, right? And what's next? I'm gonna go ahead and combine these here, right? So I'm gonna get 1 divided by cos A cos B on the top part. On the bottom part, I'm gonna get the common denominator, because if you want to think about it, you can just like combine the 2 fractions together, right? Because they multiply to each other. So technically we have like top times top and then bottom times bottom, right? So common denominator in here, 1 is actually cosine A cosine B divided by cosine A cosine B, right? So what that's saying, we're gonna get cos A cos B for the 1 plus sine A sine B for the second term, all over cos A cos B. Okay, and because this look like this, so I'm gonna go ahead and cancel them. And then if you remember from like earlier in the summary, this formula in here is what? It's one of the 6 formula that we had, right? And if I'm not wrong, it's a difference for cosine, right? So we gonna get 1 because this is the top part right here. On this bottom, now it becomes cosine, and there's a difference, right? And then A minus B. Okay, and again, what is 1 over cosine, right? It is secant of A minus B, because the angle must be like carry over, you know, like it must be the same angle, right? And this is the left hand side, so we done, right? Like this is like simpler than 8.4, I hope. Less step, but you know, like still complicated, I agree. And for your part, you have this one in here, all right? And then if you guys notice, I'm gonna recommend you guys to start from the left hand side, because the left hand side looks more like awkward compared to the right hand side from your problem, okay? Objective 3. Use sum and difference formulas in inverse trig functions. Okay, so whenever you heard the word inverse trig function, I know it gives you a nightmare. Me too. But yeah, let's just get it over with. Alright, so for my personal tips, in order to handle with inverse function, we use substitution. Okay, like you can see in the past, substitution is our friend. It's like really friendly to use. It's easy to use. Okay, but make sure at the end you have to like plug it back to its original value. Okay, don't just solve for u and then just stop there. Okay, like that's not the full work. Okay, so for example, in here, if you have psi inverse of like 1/5 in here, you're gonna let it equal to x. Okay, why? Because we need a free variable so that we can swap the inside and outside by using the definition of inverse function, just like this. And to compromise that, I'm gonna drop out like the negative or like the inverse symbol. Okay, we learned this one before, so again, if you have any questions on this one, please let me know. Okay, and then we find all 4 values, like my recommendation from before, like as long as it's sine, cosine, and because we have like 2 angles, so you're gonna find like sine of A, sine of B, cosine of A, and cosine of B. Okay, and those are my tips, right? So now let's talk about the problem that we have in here. Okay, for this one, I'm going to give you guys 2 methods. One will be easier than the other. But of course, like in the test, you don't have to do them both. Whatever is easier for you, just do it, okay? So usually, I'm going to call, like, as you can see, like from the formulas in here, the first term in here, I'm going to call it A, and then the second term in here, I'm going to call it B. Okay, so technically, we're going to have something like secant of A plus B in here. Okay, and because tangent inverse of u is a, I'm going to swap it inside out, which will give me u equals to tangent of a. And then for the second part, v equals to cosine of b. Okay, again, I'm just like swapping them in terms of definition of inverse function. Okay, if you guys have any questions on this one, please let me know. Okay. And because I'm giving you like 2 angles, 2 pictures in here and here to draw. So let's draw them out, right? Like one of them would be for angle A and the other one would be for angle B, okay? So here, tangent of A, we know that by definition of SOHCAHTOA, tangent is opposite divided by adjacent, right? So in here, u is u divided by 1. So this is opposite and this is adjacent, right? So u opposite, 1 adjacent. So then we're gonna do the thing that we always do to find the third missing side. We apply the Pythagorean theorems, and in here it has to be u squared plus 1 underneath of the parentheses. Squared underneath the squared. Okay. We're gonna do the same thing for cosine. Cosine is ca adjacent divided by hypotenuse. So we're gonna get v equals to adjacent and 1 equal to hypotenuse. Okay. So for the second picture, adjacent is v, hypotenuse is 1, right? So then the third missing sign here, it would be 1 minus v squared. Okay? I'm doing it in the short one here, but make sure in the test you have to show everything, right? I don't want you guys to, just fast forward and, jump into the answers like what I do in here. So you guys have to show the full work in order to get full credit, okay? So now let's talk about this part of doing, secant of a plus b in here. How do we do that? Well, we know that secant of a plus b, it can be rewritten as 1 over cosine. Why? Because we don't have any formula with secant, right? That's why we have to turn it back into cosine. And then the angle would be the same, which is a plus b, right? And then if you remember the formula for cosine of a plus b, it is, what is it? Let me try to remember it. Cosine of a plus b is equals to cosine of a, cosine of b, minus sine of a minus sine of a and sine of b. Okay? Alright, so now what? Cosine of a, what is it? We're going to look for this triangle right here. Cosine of a, cosine is opposite divided by hypotenuse. So, no, adjacent divided by hypotenuse. Excuse me. So we get 1 divided by square root of u squared plus 1. Cosine of b, we're going to talk about this triangle right here. Again, we have adjacent, which is v, divided by hypotenuse, which is 1, and we multiply them. The same thing will happen for sine of a, which is opposite divided by hypotenuse. And then sine of b, it is opposite divided by hypotenuse. Right? So on the bottom in here, we're going to have a 1 on the top, and then this together is v divided by square root of u squared plus 1. And these in here together, it is u square root of 1 minus v squared. I know it's weird and long, but trust me, we're almost done. Right? And because on the bottom in here, we have the common denominator in here and in here, we're going to combine them, right? Easily. So let me get some space for the work. Okay, so what we're going to do next is that we're going to do combine the two fractions together. So we're going to get like 1 minus u squared of 1 minus v squared all over the square root of u squared plus 1, right? And then at the end we just have to flip them because we have like a 1, right? Whenever you have like a threesome fraction, that looks weird, so make sure you like flip them upside down, okay? So the very bottom, this one, it will go on top, which is u squared plus 1. And then on the bottom we're gonna get v minus u, and then square root of 1 minus v squared. And this is it. Okay, that is the final answer that we get for this one. Okay, and we get this one again by using like the definition of you know, like sine, cos, and tangent, just SOHCAHTOA. That's the easy one to my like experience. Now let's talk about the second method, like the harder one. Okay, let me put it in pink because it's hard. Okay, for the second method in here, we're gonna use identities for them. So we will need to find sine of A, sine of B, and then cosine of A and cosine of B, right? How can we do that? Let's see. Let me try to find a way to explain it like best for you guys. Okay, we're still gonna go with the setup in here. Let me just highlight now because they're like important. We're still gonna set up u to be like tangent of A and then v to be cosine of B because of that inverse definition. Okay, we have cosine of B already. That's good. At least we had like one thing down, right? Like this one is down already. But now we need sine of A, we need sine of B, and then cosine of A, right? Okay, thing about to get hard. All right, let's do sine of B first because I think it's easier. Sine of B, it equals to the square root of 1 minus cosine squared. And why is this so? Because this is a part of the Pythagorean identity, okay? And in cosine of B, we have is equal to V, so this equals to 1 minus V squared, okay? So we got sine of B already. Okay, the hard part, we have sine and cosine. How can we take care of that? Well, because we have tangent of A already, so the next thing I want to do would be try to find secant, right? And secant of A, if we go ahead and use the Pythagorean identities, again, it equals to the square root of tangent squared plus 1. Okay, and again, if you don't see how the Pythagorean identity comes in place in here, please let me know, okay? And then tangent of A is u, so I'm going to have it equal to u squared plus 1, okay? So that means that the flip of it, cosine of A equals to 1 divided by square root of u squared plus 1. Okay, so we had cosine of A already in a hard way, but still we got it. Lastly, we have sine of A. How can we solve for sine of A? Well, just like before, we're gonna do the Pythagorean identities for this one. So we have sine of A equals to the square root of 1 minus cosine squared of A. Okay, and then, you know, like a lot of work in here, and then blah blah blah. I'm not gonna show it in here, but if you like good with algebra, try it yourself. I don't want to confuse you guys with this, but yeah, technically sine of A, it equals to wait, what is it? Sine of A, it equals to u divided by square root of u squared plus 1. Okay, so just like what we had in method 1, we have the same answer for, you know, like sine of A, cosine of A, sine of B, and cosine of B, but it's just a lot of, you know, like algebra in here. But luckily for the second method, you don't have to label the picture, you don't have to draw the picture because they are not necessary, again. So that's the plus side, right? Like that's a like pro. But to me, like, honestly, this is hard. Okay, when you get all the four values in here, when you get all four of, you know, sine of A, sine of B, cosine of A, cosine of B, you're going to do the same thing as we did before for this one. So I'm going to, like, repeat this whole procedure. And we're going to have the same answer, okay? So what is the difference between the two methods? Well, for method one, after the setup, you go straight to the definition of SOHCAHTOA, and then you get the four values of sine, cosine of A and B, okay? For the second method, you have to go ahead and use like Pythagorean identities and maybe like quotient identities or even like reciprocal identities, so that you can figure out like the four values in a harder way, but then at the end you still have it. So once you get all four of them, you can plug it into like the work in here, and then you get it done, okay? And for your part, this is what you have to do, okay? And again, like in the test, I will highly recommend method one because, like, personally think that the pictures are worth it. We are so familiar with the triangles already, so you guys like have an idea what to do with the triangles already. But method two, it involves a lot of, you know, like algebra techniques, and if you're not strong at algebra, chances are you might screw yourself. Okay, so don't risk. Okay. Next one, we have solve trig equations, linear and sine and cosine. Okay, this is hard. Like, just a heads up, this is hard. I know. That's why I'm giving you guys like some steps in here and some like good explanation. But if you don't understand that, that's fine. If I were to ever give this one on a test, you guys, it's gonna be like a bonus point. Okay, so don't stress out. Okay. All right. Deep breath. How can we use the sum and different formulas to apply to solve our problem, or like this? Like some mathematicians, they come up with problems like this, and we be like, what is the sum? But well, how can we apply it, right? Like, how do we know what is what? If you notice, there's actually four things, right? Like, let me circle it. Like, square root of 3 is a thing, sine of theta is a thing, cosine of theta is a thing, and there's a 1 in here because cosine of theta times 1 is cosine of theta, right? Like, that's a thing again. So we have like four things in here, four values in here. They all represent like sine of A, sine of B, cosine of A, and cosine of B, okay? But we just have to look for the proper formula to get it down, okay? So the general form for that question is this. Generally, we're gonna have like numbers A, B, C, and we're gonna have like some sine theta. We're gonna have some cosine theta, right? So what we're gonna do is that we're gonna use this formula, the sum of sine, okay? And then as you can see, sine of theta in here, it could be, you know, like B. So what is it? So A in here is sine of alpha, B in here is cosine of alpha, while sine of theta in here is cosine of beta. Hold up. Give me 1 second. Let me put my thoughts together on this one. Alright, so start again. Cosine of theta in here, it can be thought as, what is it? B in place of sine of beta. Oh, yeah, I got it. So cosine of theta in here, it can be used at cosine of alpha, and sine of theta in here, it can be used as sine of alpha. Okay, so technically alpha is theta. Okay, for the other one, let me put it in pink. A in here is actually cosine of beta, and B in here is actually sine of beta. Okay, just like what I had in here. Okay, A for cosine and B for sine. Okay, I know it's confusing. I know it confuses me already. But yeah, let's see what we have in here. So tangent of B by quotient identity, it is sine of beta divided by cosine of beta. And because they are like B and A, that's why we're having this in here as B divided by A. Right? And then after that, we're going to do like the inverse tangent of B divided by A, and then we end up having an angle theta. After that, we can go ahead and plug that angle theta into sine and cosine value to get cosine and sine values, right? So once we have like two of them, we can plug them into the formula, and then we can proceed to work, okay? These are actually like the step to do it, and let me not explain them too much. And let me get into the first example, and then while I'm doing the first example, I'm going to show you guys what it means by like each of the step in here, okay? So first, we have to find r, okay? First thing first, find r. How can we find r? Well, r equals to the square root of the front numbers before sine and cosine. And here we have a square root of 3, and here we have an indivisible 1 in here. So technically, we're going to have square root of 3 squared plus 1 squared. Okay? And then if you put the whole thing into the calculator, it's going to give you 4 in here, and the square root of 4 is 2. So our radius, or our r in here, is 2. Okay? So now, next step, we're going to divide everything by r. Okay, so we got this down ready. That's good. And now we're going to go ahead and divide everything by r. So how does it look like? Square root of 3 divided by 2, and then sine of theta because it's there from the beginning. And then this one, I cannot read it. So yeah, plus a half because 1 divided by 2. And then cosine of theta is just from there. And now on the right hand side, we're going to do the same thing. We divided by r, so we're going to get 1/2, right? All right, next part. Now, because this is sine already, so this has to be equal to cosine of the angle that we're looking for, and we use like beta in here. So if you want, you can use beta also. And because this is cosine ready, so this is our sine of beta. Okay, and because we have sine and cosine ready, so we're gonna do tangent of beta, which equals to sine divided by cosine, 1/2 divided by square root of 3 divided by 2. If you put it into the calculator, you're gonna get square root of 3 over 2. Square root of 3 over 3, okay? And if you see that this value is familiar, it is because it is one of the value in the 30, 45, and 60 sine, cos, tangent table, right? And square root of 3 divided by 3 is actually here. So beta in here equals to the angle of 30 degrees. Or should I say pi over 6. Okay? And we know that sine of pi over 6, sine of beta or sine of pi over 6 in here, it is this guy in here, 1/2. Cosine of beta or cosine of pi over 6 in here is this guy in here, square root of 3 over 2. And it matches with our expectation in here, right? So that's good. And that's like really good and ready. So now what we're going to do, right? We're going to combine them into this formula in here. We're going to need a sine and then 2 angles, right? So we have a sine here. The first angle is the one that we're looking for, theta, because it's given from the problem. Second angle is the one that we just found, pi over 6. And then on the right hand side, we're still going to have 1/2. Okay? So now this is back into, you know, like 8.2 or 8.3. I don't remember which one it is, but then this one is back into like summary for the 2 angle families, right? So again, we have to, you know, like find a unit circle, which points are like which angles has the y part of 1 over 2, and then after that we have to find like 2 of them by shooting it by shooting the first angle across the the y-axis, right? So fast forward to this one. I'm gonna get to angle family as for 1/2. What do we have? Pi over 6 and 5 pi over 6. Okay, so in here, theta plus pi over 6 equals to pi over 6 as the first angle plus 2k pi, because we can go for like multiple circles in there. And then the second angle family in here, it is 5 pi over 6 by looking across from the y-axis from pi over 6, okay? And again, we can go for multiple circles in here. And then let me get rid of some of the work in here before we move on. All right, so what do we have next? Well, we have to solve for theta, right? So for each of the case in here, theta in here, well, these cancel, so it's gonna be 2k pi. And then theta in here, it is, 5 minus 1, which is like 4 pi over 6. So 2 pi over 3 plus 2k pi, right? And again, if you're looking back at the problem, it's asking us to go for within a circle, right? So what does it mean? Well, we have to plug in k values for k. And in here, for the first family in here, k can only be equal to 0, because if you go for like k equal to 1, you're going to get 2 pi. And if you look at this restriction, we don't even have 2 pi, right? So in short, this will just take the angle of 0, and that's it. Okay. For the second case, similarly, we only get the value of k equal to 0, because if k equals to 1, we're going to get something like out of a circle. So for the second case, I'm going to get something as 2 pi over 3, okay? And these are my final answer. Okay? And again, I know this is hard, but I mean, like, try your best, okay? If you don't get it, that's fine. It's just going to be a bonus question, okay? Next up, we have the last objective of the day. I mean, it's not even like an objective. I'm putting it there because I know for sure I'm gonna give you guys something like this on a test, and it's like a little help page for the homework, anyways. So that's why I decided to give this one to you guys. It's similar to the UV that we had earlier. So I think it should be easy, but let's see how it goes. Okay. So again, we're gonna have two angles in here, A and B. If you want to refer them as alpha and beta, I'm cool with it. Because like I don't like Greek letters also. So in here, we have to solve for psi of A plus B, right? Like in terms of, you know, like alphabet, English alphabet. So we have to solve for psi of A plus B. Tangent of A is negative 5 over 12. And we know for a fact that tangent equals to opposite divided by adjacent, right? And alpha lies in quadrant 4. That's a good like info. So alpha A, it's in quadrant 4, right? So 1, 2, 3, 4. We have alpha in here, so let's make a dot somewhere, and then let's draw like a right triangle in here. And this one, usually we call it theta, right? But because in here we have like A and B, so this one is actually angle A, okay? And let's finish labeling this one before we jump into the second angle, or like second triangle, okay? So opposite to it, we have a negative 5, and then adjacent to it, we have a 12, right? So first thing first, solve for the third missing side, right? And I'm gonna fast forward to this one. We're gonna have a squared of 12 squared plus 5 squared, and that is 13. Hypotenuse is always positive, okay? So make sure you don't put like negative 13 or anything weird like that in here, okay? It has to be a positive 13, okay? Now let me put the outer angle in pink. So we have psi of B equals to negative 1/2, right? And psi, so is opposite divided by hypotenuse. And we know that beta, angle B, it has to be in between 180 and 270, right? So if you go ahead and label 180 and then 270 in here, if you remember the 4 quadrant angle, you will soon realize that angle B has to be on the third quadrant, right? So make a dot in there, like I don't care what it is. I mean where it is, but yeah, just make like any dot that you want to, and then you're gonna have like a right triangle, right? And this angle right here is B, right? Opposite to it, we have negative 1. Adjacent, hypotenuse, we're going to have a 2. And to figure out the third missing side, we're going to do square root of 2 squared minus 1 squared, which is square root of 3. Okay, and let's just double check on the side to see whether it's a positive square root of 3 or negative square root of 3, right? If you notice, this sign here is on the left hand side of the x-axis. That means it has to be negative. Okay? So just because we figure out a third number or the third missing sign here, it doesn't mean it has to be positive, right? So just keep in mind it could be sometime negative also. Okay. So now let's get to the work. We have to find this in here, right? And psi of A plus B, it equals to, here, let me pull back the formula real quick. It equals to psi of A cosine of B plus cos A psi B. Okay, let me plug everything in here. Psi of A, what do we get for psi of A? A in here, let me put it in red. Psi of A, we're talking about this picture right here. Psi is equal to opposite divided by hypotenuse. It means that we have negative 5 divided by 12. And then let's talk about cosine of B. We talk about this triangle right here. Cosine of it equals to adjacent divided by hypotenuse. And in between, we're going to multiply them, right? And then back to angle A with the red. Cosine of A in here equals to adjacent divided by hypotenuse, which is 12 divided by 13. And then back to the pink triangle, we have multiplication. And psi of B, it equals to opposite divided by hypotenuse. Okay? As for the final answer, we're gonna multiply everything together and then we put them into the calculator, okay? So, wait, I feel like there's something weird here. Okay, I think this one should be a 13. If you guys agree with me, because the hypotenuse for triangle A, or like for the angle A, it should be 13, right? For some reason, I put like a 12 in here, but I meant 13, okay? So lastly, putting these together, top times top, we're gonna get 5 square root of 3. Bottom part, we're gonna get 26. And for the other one, we're gonna have a minus 12 divided by 26. Right? And I mean, you can call it the answer, or if you want, you can like simplify these by 2. So on the top part, we're gonna get a 6, and on the bottom part, we're gonna get a 13. So 6 and 13. If you want, you can think of it like canceling here. This is 1 and this is 6, right? And then this is the final answer. Okay? So you don't have to do this one. It's just like, you know, like a help page for me to help you guys on the homework. So if you have any questions on this one, let me know. And make sure you guys study this one like well. Let me put like, I don't know, a booster on this one, because this one will be on the test and also on the quiz. Okay? So again, thank you for your listening. Take care and have a great day. Bye-bye.